Hi, welcome to another mini lecture on pre-calculus. The topic today is very similar to the previous one, graphing an exponential function and its asymptote. The general form is given to us as a times exponential of x minus b plus c. And here's an example. Let's go ahead and do this the way your software wants you to do it, and then we are going to talk a little bit more beyond what the software is asking. So it's asking very little here from you. It's just asking you to plot 2 points and draw the asymptote. Well, if you want to have a function drawn, typically 2 points is not going to be enough, but here's what's asking us. And so what you go ahead and do here, make a table x and 3 exponential of x minus 4 plus 1. Perhaps the main thing to learn here is the order of operation and how to interpret the meaning of this 3, 4, and 1. Okay, we go choose two x's, any x's would do, find the values here, and your best bet is to use this to plot your point. So instead of using the pen, you use this one because pen is not going to be accurate enough, and point plotter for us is going to do the job. So let's go ahead and find an easy x to plot. What's easy x? Easy x is what makes it exponent to be 0, because no exponential of 0 is going to be 1, and we're all done. So what x makes this thing 0? So of course that is just 4. At 4, this exponent is 0, so 3 times exponential of 0 is just 1 times 3, that's 3 plus 1, it becomes 4. So accidentally it became the same number. And then you can just plot 0.44. But that's the only easy point that we have here. So for example, if you go ahead and find some other point, it doesn't matter what. Here, for example, 6. If I find 6, it becomes 3 exponential of 6 minus 4 is 2 plus 1. Okay, instead of using a calculator to find this thing and the point plotter to go ahead and approximate this thing on the graph, which probably would not be acceptable by the software for you, you want to go ahead and use this software. So let me just go ahead and show it to you. So we have, I guess here, somehow I got the different numbers. Let me see. Yeah, okay. So when you click on this one, it tells you how to go ahead and plot this thing. We said at 4, when x is 4, we don't need any help, it's just 4, and then we plot that point, so no problem there. What if we had 6? At 6, you go ahead and enter, so the function itself was 3 times, so it's going to be 3 times exponential of, you can either click on E or just enter E, so exponential of 6 minus 4 becomes 2, and then you use the right arrow to go to the right, and then just plus 1, and then you plot your point. It's complaining that we are too far out of the picture, so let's go back and choose something else. So good that we tried this thing. So let's go ahead and choose, for example, 3. When x is equal to 3, my exponent is going to be minus 1, so 3 times exponential of, here I'll have minus 1, and then that is going to be my point. So let me check again to make sure I got at x is equal to 3 and 3 exponential of minus 1 plus 1, plot the point. Notice it tells you do not approximate, so you cannot use a calculator or anything. So we have the point plotted. We are done with this unless you want to plot more points. Here is our plot. That's odd. So let me erase this thing. Erase the plot. I'm not quite sure. Let's draw the horizontal asymptote. It's horizontal asymptote. When x goes to minus infinity, this becomes 0. Horizontal asymptote is just 1. So we go ahead and graph this thing at 1. And then I come here and plot my function. And now it does the graphing correctly. Okay, so that was a bit weird here, but you get this thing done. Now let's go back to our page. So what is there to learn here? We just learn a little bit about the software, how to enter, how to get our graph going, and so on. But well, where is the mathematics in all of this? So let's go ahead and say we are going to do this thing all by hand. What are the issues? So 3 times exponential of x minus 4 plus 1. That's the function we want to graph. What's the meaning of those things? Just like last time, we have exponential of x. When you change your x to x minus 4, what does that do? We said this means move right by 4 units. Then what is next? Then the factor of 3 comes in. So 3 times exponential of x minus 4. That's going to scale by a factor of 3 in a vertical direction. So scale by factor of 3 vertically. So whatever the function was, it has to be tripled. Then final stage, 3 exponential of x minus 4 exponential of x minus 4 plus 1. What does 1 do in all of this? This lift up by 1. So the meaning of this one has to be read as b to right. This a, we understand by that scale by factor of a, meaning multiply the vertical dimension by a. Scale. So scale means multiplication vertically by factor of a. Multiply by a. That's a different thing from lifting by c. Lift up by c. Now let me try to show this thing to you another way. Hopefully we understand the significance of A, B, C. So again, notice we are going beyond what the software is asking. The software is just asking us to click here and there, and then we are going to be done. But really, to understand this function, you need to understand the significance of A, B, and C. What do they mean physically? So let's go to this page. Okay, so we are going to experiment here with this concept we just mentioned. So I'm going to have this basic graph exponential of x. Next thing I'm going to do is to shift it by b. When I subtract by b, put a positive number for b, then I go to the right. Let's see. Here, that's what's happening. So I'm going to the right. So for example, by now I've shifted this thing to the right by 2 units. Here I've indicated for you by these black lines that we have moved to the right by 2 units. But if I want to go 3 units, well, stretch this thing more, 3 and then 4 and so on. What if my b was negative? Well, I go in the other direction. So this is a horizontal shift. When we subtract something from x, our graph goes to the right by that amount. Now let me undo all of this shifting. Next is, what is it that the a gonna do? So let me turn on this graph. At the beginning there's nothing happening, but now I'm going to change my scale factor a. When I change it, you see this green, the new green function is obtained by multiplying the blue one by a. So here my a is 2.5. The green is 2.5 times taller than the blue. To make this thing stand out for you, let me go ahead and turn this switch on. So let's go back up here. I have drawn two green vertical lines. You notice, for example, here one is scaled to this location, and this one, whatever it is scaled to that location. Notice it's not a vertical lift, it's by multiplication. This point is lifted by some amount, this one by a different amount. So we, instead of using the terminology of lifting, we are going to say we are going to scale. So here I'm scaling by a factor of 4. So this was like 1, I'm coming all the way to 4. This was almost 2.2. This was this is 3, so this is almost 2.75. Multiply that by 4, I almost get 11. So whatever the height is being multiplied. Now what if I multiply by a small number? You see, that's going to shrink my function. So my a is 0.5. So this 1 becomes 0.5. Whatever this point is, for example, is like almost 7.2. When I divide it by 2, I get almost 3.6. Again, to see what if I do negative? Well, if my a is negative, excuse me, if I go to negative a, it means other than multiplying by number, I'm also flipping across the x-axis, because I'm multiplying my y value by a negative number, so it becomes negative. So for example, if my a was negative 1, here let me adjust it to negative 1, the green is the reflected version of the blue. Okay, let's go back to a is equal to 1. Now I am going to go do one shift, so I'm going to go to the right. So I've done shifting, let's shift by 4 units, and then let me scale afterward. When I scale, notice I separated. So I started with the red, I shifted it to the right by 4 units, and I got the blue. Now I'm taking that blue and scaling it. You notice it's the green that's being born, it's so many times bigger than the blue. Okay, so for example, here let's adjust a to be 5. This green function, let me lower it. This green function is 5 times taller than the blue function. Okay, I hope that you learn what is the significance of a, b, c in this problem. Let's go back. So again, learn about shifting, horizontal shifting, vertical scaling, and uh, vertical lifting. So this plus one at the end is going to be our uh, agent for changing the location of the asymptote. It's going to change by one, by being lifted up by 1 unit. Okay, uh, probably this is going to be end of the questions of this type. I hope you try many examples like this so that you become fast in detecting where the graph is to be. So try to work the problem in your mind by translation and scaling, and verify your answer by what you get from the software itself. So until next time, good luck and God bless.